So in this last video of this lecture, we will re-estimate the sample size. So we are performing an experiment, and in the middle of the experiment we will change the sample size that we think we need based on the estimates of the probability of respondents, and without disclosing, and this is very interesting. So we will do a blind experiment and we will not disclose the labels, but still we will be able to re-estimate the sample size. Okay, so let's say that we are evaluating the efficacy of a new drug with respect to a reference drug. We have estimated the sample size to be n equal 18, and we are performing an interim test, only one, so we have two stages, and we record whether a patient responds or not to the treatment or control. The study is being performed in a double-blind way, so and we don't want to disclose the labels. So how can we, at the interim test, use the collected data to readjust the sample size? Okay, so this is called the sample size re-estimation problem, and the solution depends on each kind of study being performed, but here is the solution for proportions. Okay, so let me note P1 and P2, the proportion of responders in group 1, that is the treatment, and group 2, that is the control, and Yj will be the response, that is 1 or 0. And then we do not know if a given individual, because of the double blinding, we don't know if it is receiving the treatment or control, and we assign it randomly to stratum A. So at this point we know that the individual is responding, but we don't know which drug it has been given. So we will assign it to stratum A. So at that point we will make it in two parts. So stratum A with probability pi, this pi is a number between 0 and 0.5, and stratum B with probability 1 minus pi. So the probability of responding in A is this one. It can be calculated to be this one, and we know it is the number of respondents of the people in group A. So we know how many have responded. We don't know the drug label, but we know that this proportion of respondents in A has to be this one, and the same for B. So now we can solve for P1 and P2. So without disclosing the labels, we can estimate what is the proportion of respondents in group 1 and in group 2, so in the control and the treatment, and then we can re-estimate the sample size. And so for instance, let's say that pi is equal to 0.4, and we observe a number of respondents in the stratum A 0.6 and in stratum B 0.5, then these are our estimates of P1 and P2, and the re-estimated sample size will be this one. So instead of 18, we can go down to 13. So in summary, all these adaptive sample size calculations, they all split the experiment into small stages. We have to add extra samples to account for the multiple testing, but they are very useful because they allow us to stop the experiment if we have a lot of evidence that it is working, or if we have a lot of evidence that it most likely it will not work, and they also allow us to re-estimate the sample size at intermediate steps. So with this, this would be all for the adaptive sample size calculations, and then we see you in the next topic.